All right, guys, good to see you. Welcome back to the Former Farm Kid channel. Today we're talking about translations, and we are, excuse me, given the problem of triangle XYZ, which has the coordinate of -2, 1, -1, 3, and -4, 2 for its three vertices. So we are not asked to draw in this particular problem, we are not asked to draw the translated figure, but rather to create the translation equivalent for the reflections that we are given. So here we have the x-axis, and here is the y-axis, which I have also made blue because it is an axis of reflection. We are also told that line M is equal to x equal, well, 1, 2, 3, 4, 5. X equals 5. So here's my second line of reflection because I'm given 2 in this particular problem. And let's look at these now. So on our reflection problems, we actually read these right to left. So, well, I shouldn't say read necessarily. It depends on what your teacher shows you. But what you really need to know is that the second one written is the first one done. So it's asking me to reflect these 3 points across the y-axis. Point X is -2, 1, and I've drawn that in here at this position, so it'd be -2, 1, and I'm told to reflect it across the y-axis. Well, if I was going to do the whole triangle, I would have all 3 points labeled. But since I'm just coming up with a translation I call rule, some textbooks call it the equivalent, translation equivalent to these reflections, I really only need 1 point. So I don't want to overly complicate my reflection problem here. Why reflect all 3 of these points when I'm only trying to come up with the translation rule? So I'm just going to pick a point. I could have picked any of these basically. I kind of would like to choose the very easiest one. They're all really about the same. X is negative, Y is positive, so it doesn't really matter. So at any rate, I drew in point X, which is -2, 1. The first thing I want to do is reflect it across the y-axis. So if it's 2 to the left here, it's going to be 2 to the right here. So here's my first point of reflection across the y-axis. Notice I'm not doing anything with the y's. The y distance is going to stay the same. So if it's up 1 here, which it is, it's going to be up 1 here. It's going to be up 1 on the second reflection. So here's my first reflection. And some text will show the first reflection as x prime, and this would be double prime, I call it. They basically will call this the image, final image. This is the pre-image. It's what you're going from to. All right, so my second reflection, by the way, when 2 reflections are drawn together, some textbooks make a simple little circle between the 2. Some texts do it differently. This is a Pearson text, so this is the way they do it. So now I am at this position here, and I am told to reflect X after this reflection across line M. Reflect across M. Well, M here is X equal 5. So I'm going to look at this. This is 5. So it's 1, 2, 3. So I'm 3 units from M. I need to go 3 units over here. 1, 2, 3. So here's my final reflected X image from the pre-image of X. So as I can see, so if I want to write this rule, I'm going to write it that this reflection is equivalent to the translation of triangle, I'm going to put that second, triangle x, y, z by, the first coordinate pair is going to be the left or right. Well, how many places has it gone in the x direction? And we could just add these up. Well, there's 8 here, there's 2 here, so that's 10. That's pretty easy to do. How many has it moved vertically? Well, like we said before, we're not asked to reflect across a line across the y-axis. I'm sorry, across the x. We're not asked to reflect across any x-axis. There are none drawn in here anyway. These are all x reflections, not across a y reflection. So since y hasn't changed, my second coordinate is going to be 0. You may have noticed this 10 is equivalent to 2 times the distance, the difference in distance of the 2 lines of reflection. In this case, if you notice, here's my first line of reflection, here's my second, so it's 1, 2, 3, 4, 5. Well, 2 times 5, the difference in the 2 lines of reflection, are equal to the movement in x, and that's exactly what I came up with. So if you're asked to draw the picture, this is what it would look like. Of course, you'd have 3 points for all triangles, but this problem only asked for the rule. So technically, would I need to have done any of this? No, not really, because I know that the y-axis is x equal to 0. My second line of reflection was 5, or m is x equal to 5, so it would be 2 times 5, or 10. So that's how we come up with the translation rule. Okay, guys, keep up the great work. God bless. Any questions? Give me a holler on the comments page. See you next time.